Hey guys, welcome to 13.2. We're going to be talking about some more probability. We're going to kind of recap what you guys learned last time real quick. So we have the probability of x. So anytime I'm trying to find the probability of something, we need to have the number of blank over number of blank. So I want you to think about what that is, pause the video, fill that in, and see if you got it correct. Alright, so it's going to be the number of successes over the number of possibilities. Okay? And we'll kind of explain that more in the next slide. This right here is also a recap from last class. So if you want to pause and try to fill this out, then go for it, and then I'm going to fill it in and kind of talk about it. Right, the theoretical probability, so when we're comparing the two, it's going to be the same for each one of these. And the reason is because anytime you roll a die, you have a 1 out of 6 chance of getting a 1, a 1 out of 6 chance of getting a 2, so on and so forth, all the way down. And I'm going to also put that in decimal form, so remember how to do that. Just divide 1 divided by 6, so it's going to be 16.7%. We will just call it 17%. Okay, I'm just going to do this all the way down. Okay. So that is the theoretical, that's supposed to be 17, kind of hard to tell. That's the theoretical probability of rolling a die. But, if you remember last, we rolled the die 30 times. And then here's some possible data from it. And so, when working experimental probability, you guys remember you rolled it 30 times, so it's number of successes over number of possibilities. Twice we rolled a 1 out of the 30 times that we rolled it. So that's going to be a 1 out of 15. Right, and then we're going to convert that to excuse me, a percentage as well. So 1 divided by 15 is 0 and then 6 repeating. And so we're going to end up rounding that to 7% because you've got to move the decimal over 2 spots to get your percentage. Okay, and then we rolled a 2 7 out of the 30 times. So 7 divided by 30 is 23%. I'm just going to go through all of these. 6 divided by 30. Remember, it has to be a reduced fraction, so we're going to reduce it to 1 over 5, which is a 20% chance, or, excuse me, it's 20% of the time we rolled a 3. Okay, and then for 4, we rolled it 3 out of 30 times, which is 1 out of 10, or 10% of the time we rolled 4. 8 out of the 30 times we rolled a 5. So that's going to be 4 over 15. And sorry, it's a little bit, it's easier to see now. Now you guys can see the side. And then 4 divided by 15 is 0.2 and then 6 repeating. So that will round up to 27%. Then the last one, 4 out of 30, simplifies to 2 over 15, or 13%. Okay, so this just kind of shows you how you can compare the theoretical to the experimental. Theoretically, you'll roll each one of these around 17% of the time. But if you notice, you never actually rolled any of them 17% of the time. 3 of them, you rolled less than 17. The other 3, you rolled more than 17% of the time. Okay, so that was a little recap from last time. Now we're going to hop on to some OR probability. So this is the new stuff for today. The OR probability is talking about what is the probability if for me to roll a 2 or a 3. So if I roll the die one time, what's the probability of rolling a 2 or a 3? Okay, and then this is just another way to write it, and it talks about it down here, the union symbol. So if you hear me say the word union, that is another way to write OR. All right. And then something that's very important, I want everybody to write this, OR means add. That's very important. It's like there's going to be 2 really important things that you need to know today. We're going to be talking about the words OR and AND. OR means add. Okay, so what does that mean? I'm going to take the probability of rolling a 2 and the probability of rolling a 3. So we're dealing only with theoretical probability right now. So I have a 1 out of 6 chance to roll a 2. Why? Because, a die has 6 sides. If I roll a 2, I have a 1 out of 6 chance of it. Same thing for, oh goodness, rolling a 3. I accidentally wrote 3. You have a 1 out of 6 chance to roll a 3. So if that's the probability of those two separately, the probability of rolling a 2 or a 3 would be to add those two probabilities together. So 1 over 6 plus 1 over 6. Remember, the denominators are the same, so that's good. That becomes 2 over 6, and then simplifies to 1/3. So that is the probability of rolling either a 2 or a 3. You have a 1 in 3 chance of rolling that, and percentage-wise, that would be 33% chance. So I'm going to answer all of them in percentage or fraction. It can also be decimal form, 0.33. These are the different ways to write probability. Right there. 3 different ways. Okay, that is the gist of OR probability. So let's do some examples. All right, I'd like you to stop the video right now and try to figure out what's the probability of a 1 or a 6. Okay, and I'm just showing you all the different ways that you can write it. Okay, the probability of 1 or a 6 is this. Pause it if you haven't already figured this out and then come back. Probability of 1, probability of 6, they're both over 1 over 6. So if you notice, it's the same as the example before. You're going to add them because this means OR. Two over 6 is what you get. And voila! You have a 1 out of 3 chance of rolling either a 1 or a 6, which is a 33% chance. Awesome. So for this next one, I'm actually going to go to the Pear Deck so we can see this in color. Okay, and we really just came to look and see, for this example, which ones are blue. So the 7 and the 5 are blue. So I'm going to go back to my other sheet and mark those. That way I can write on my paper. Okay. Oh, that's where my paper went. It's like, where'd it go? Okay, right there. So 2, a 3, or a 7. These two are blue. Okay. So our P2, our 3, and our 7 are what we're looking at right now. And we need to know the chances of rolling a 2 or a 3 or a 7 and then add them all together. So you have a 2 in 8 chance, or sorry, you have a 1 in 8 chance of rolling a 2. So that's where it gets confusing. So make sure there's only one wedge of 2 out of these 8 wedges. So 1 over 8, that would be our P2. Our P3 would be 1 out of 8, because there's 1, 3 out of the 8 wedges. And then same thing for the 7. There's 1, 7 out of the 8 numbers. Goodness, I need to write this and not talk at the same time. So you have a 1 in 8 chance of rolling a 2, a 3, or spinning, excuse me, a 2, a 3, or a 7. And it's the same idea. Anytime you have or, you're going to add. So you have a 3 out of 8 chance of rolling that, a 2, a 3, or a 7, which is a 38% chance, or a 0.38, depending on how the question is asked, in decimal, percentage, or reduced fraction form. All right, moving on. Last one. So use the spinner to find the probability of blue or the probability of even. So what we're going to do is count up the blues and go ahead and figure out what that number is. And then we're going to count up the even and figure out what that number is. And then we'll add them together. So there are, as we saw earlier, there's 2 out of the 7 of these are blue. Or sorry, there's 8. 2 out of the 8, goodness. And I'm actually going to wait to reduce this because when we add them together, we want them to have a common denominator. So I don't want to reduce it yet because then we'll just have to find the common denominator again. And then how many even are there? 2, 4, 6, 8. So there's 1, 2, 3, 4 out of the 8 of them are even. So 2 of the 8 are blue, 4 of the 8 are even. Now we're ready to add together. You get 6 over 8. Now is the time that you want to simplify. Okay, so 3 over 4 is what it simplifies to. 75% of the time, you are going to spin something that is blue or something that is even. Okay, because it only leaves 2 things. It's just the 1 and the 3 are not either blue or even. Okay? Cool, so we're moving on to AND probability now. Our AND probability is slightly different. So if we notice the difference in the symbol, this is an intersection symbol. And it means AND. Intersection symbol, it's another way to write AND. Okay, and so what if I ask for P2 and P3? So that would be 2 separate events where I would have to roll P2, and then I'd have to roll P3. Okay, so I'd have to roll both of them. So instead of either or, now it's AND. So this is the important thing. Remember, or meant add, and means multiply. Okay, so we have our P2, we have our P3, which the probability of 2 and the probability of 3 is not going to change. You still have a 1 in 6 chance of rolling either one of those. The difference is now you are multiplying. Okay, so when I multiply, I would get 1 over 6 times 1 over 6. So I'd end up with 1 over 36. So it's a much lower probability to get a 2 and a 3 than it is to get 2 or a 3. So 1 divided by 36 is actually just a 3% chance. So I want you guys to notice the difference between these two. The or probability had a 33% chance. The and probability where you multiply is only a 3%. Or a 0.03 probability. Okay, so these are going to look a little different than our or. Notice these are all the same questions as we did for the or, but there's going to be some differences because we're using and. Except, okay, I fixed it. I noticed that these were still said or. They now say and. That's what they're supposed to say. So we want to use this guy for this one, and we want 1 over 6. So if you'll pause your video and figure that out and then make sure you got it correct. It's going to be very similar to the one above on the slide before. So it's still 1 over 6 chance for both. We are multiplying because this means and. Oh, goodness, I can't spell. Means and. So you get a 1 over 36 chance, or 3%. Okay, this next one, it's now 3 events. So now this is the probability of rolling a 2, and then rolling a 3, and rolling a 7. They're just like you have 3 tries, and you roll a 2, 3, and a 7. Doesn't necessarily have to be in that order. But what are your chances of rolling those 3 in 3 spins? Okay, so my P2, my P3, and my P4, so that's a probability of 2, 3, oh, this should have been a 7. I just kept going. They're all 1 over 8. Because there's a 1 out of 8 chance to roll any of these numbers on here, or to spin any of these numbers. But we want to multiply all of them. So it's like we have 3 separate events. What's the chance that these 3 are your outcomes? So it's actually going to be 8 times 8 times 8. 1 over 512. It's going to make this tiny number, 1 divided by 512. So look at what we have going on here. Our decimal, 0.002. We're just going to round it. When I make this into a percentage, I'm going to go 2 decimal places over. And it's going to be 0.2%. So you have a very tiny chance of, if you roll the spinner 3 times, landing on these exact numbers. Okay? Alright, and then this last one is, what is our probability of rolling blue or spinning blue or an even? Okay, it is the same as before. So this one, the 5 and the 7 are blue. And it's on the pair deck in case you guys just want this for a visual. But both of these are blue, and then we'll count the even. So we're going to count our blue, which is 2 out of 8. We're going to count our even, which 4 of these are even. 2, 4, 6, and 8. So 4 out of the 8 are even. And then if you guys remember last time, I told you, don't simplify. I'm going to say the opposite this time. But I want you to think logically about it, like, why would we want to simplify these? Well, if we are multiplying these, we want smaller numbers, right? So I would much rather multiply 1 over 4 times 1/2 than multiply 2 over 8 and 4 over 8. The numbers would be a lot larger, and we'd have to simplify. So we're going to multiply the probability of blue, which is 1 over 4, times the probability of landing on an even, which is 1/2, we will end up getting 1 over, and then 4 times 2 is 8. So for 1 over 8, to put that into a percentage, we would divide 1 divided by 8 is 0.125. And for a percent, if we round it to the nearest percent, it would be 13% after we move our decimal place over 2 times. Okay, so you won't get it wrong if you multiply 2 over 8 and 4 over 8. You will just have to simplify this fraction because you didn't simplify it before. Let's remember why we don't have to simplify it. It's because when we're multiplying, we don't have to have a common denominator. If you were adding, you would want to simplify. Okay, we're going to move on to the advanced questions. So for the advanced questions, we have this right here, which I am going to need to switch over. So give me just a second. Okay, this is much prettier. We now have a pile of 34 M&Ms, and we're going to talk about the difference between with and without replacement. So we have 34 M&Ms. We want the probability of red and yellow. So we've already done this. We're going to do this slide. This is just and probability. Okay. Okay, so we want the probability of, if you have these 34 M&Ms and you just pull out of a cup, you pull 2 of them, what's the probability of pulling a red and pulling a yellow? So we're going to start by, you pull the first one, and then you replace it, and then you pull the second one. This is called with replacement. So it's really just the same as what we talked about before with and means multiply. That's the same thing. And we have our probability of red. So there's 1, 2, 3, 4, 5 red out of 34. Oop, there we go. We're going to multiply that with the probability of our yellow. So I'm going to change colors. We'll go with pink. And there's 1, 2, 3, 4, 5, 6, 7, 8. 8 yellow out of 34. And so we're just going to multiply these. So 5 times 8 is going to be 40. Well, actually, I'm going to pause real quick. I'm going to go ahead and simplify this one. And the reason I want to simplify it is because if I simplify it now, I don't have to simplify it later. It's going to be easier to do that. So instead of 8 over 34, I'm going to simplify it to 4 over 17. All right, so I'm going to get my little eraser and change this to 4 over 17. So just so you guys can see it, I'm going to circle where it's like a little bit color-coded. The red is this purple color. The yellow is this pink color. We'll do red. So 5 times 4 is 20. When we multiply, you get 20 over 578. And that's 34 times 17. Then we want to simplify this because both can be multiplied by 2. So you get 10 over 289. So 10 divided by 289. And then we want to turn that into a percent. So I'm going to divide 10 divided by 289, and I get the decimal 0.033 4, 6. And so if I want to put that into percentage form, I'll change it to green. I'm going to move this decimal over 2 times. 3.5%. If it asks for the nearest tenth, it would be 3.5%. If it asks for, the whole percentage, the percentage is a whole number, it would be 4%. Well, actually, it would stay as 3%. So that gets a little confusing. So if it asks to the nearest tenth, this 4 would round up to a 5, it'd be 3.5%. But if it just asks for it as a percentage, this 4 would not round up to 3. Okay? So that is with replacement. All right, now we're going to talk about without replacement. That's a pretty simple concept. I'm going to clear these drawings. I'm going to go to the next slide. And now we've got the same thing. So PR and PY is just for my PR. So I have a 1, 2, 3, 4, 5, same thing, a 5 out of 34 chance to roll, or not to roll, to choose a red. And then I have my yellow. So let's just think of it as you have your little cup of M&Ms. If you pull out a red and you don't replace it, so it's called without replacement, then what would happen is you now only have 33 M&Ms in your pile. But there's still 8 yellows. Okay? So you then have an 8 out of 33 chance. Oh goodness, struggling. You have an 8 out of 33 chance of pulling a yellow because you did not replace this red one right here. Okay, so when we multiply, 5 times 8 is 40. Then you have a different number. 34 times 33 is 1,122. And that's going to simplify to 20 over 561. And then when I turn this into a decimal, 20 divided by 561 will be a 3.6% chance of occurring. And then it's asked, did my odds get better or worse? And that's why I answered it to the nearest tenth, because my previous slide was a 3.5% chance. This slide was a 3.6% chance. So yeah, my chances slightly increased. My odds did get a little bit better by 0.1%, because we took one of the M&Ms out, so we had a better chance of getting the yellow the second time. Okay? All right, last couple slides here. So what if I ask for the probability of B or Y? So now we have or, and or means add. So or means add. So that's important for what we're about to do. All right, we want the probability of blue. So we've got 1, 2, 3, 4, 5, 6, 7, 8 out of these 20 M&Ms are blue M&Ms. All right, so I've got, so for this, I'm going to do 8 over 20. And that is going to be for blue. For my yellow, why don't we do it in orange? Why not? 1, 2, 3, 4 out of the 20. Actually, it's 4 out of 19. So I didn't read this very well. It's without replacement. So my first draw, I've got an 8 out of 20 chance of getting blue, but I don't replace that blue. Then I pull my yellow, and I have a 4 out of 19 chance of getting the yellow. So we've got 4 over 19. And I want us to look at this. If you notice, earlier when I talked about OR and adding, I said don't simplify your fraction because you need a common denominator. Well, these don't even have a common denominator. So I'm going to go ahead and simplify this fraction because it's going to make my life a little bit easier. So instead of 8 over 20, I'm going to change that to 2 over 5 because I can, divide both of them by 4. Now, when I make my common denominator, it's going to be a little bit easier. So I've got 5 and 19. I'm really just going to multiply this 5 times 19, and 95 is going to be my common denominator. I need to change colors. That would be better, wouldn't it? We'll go with this. So 95 is going to be my common denominator because that's what 5 times 19 is, and there's not a smaller number that would work. So we need 2 times 19, which is 38. Since we multiplied the 5 times 19, we also have to multiply the 2 times 19. So we have 38 over 95. We're going to add that. This 4 needs to be multiplied by 5 because that's what we multiply the 19 by. So we get 38 over 95 plus 20 over 95. 38 plus 20 is 58. There we go. Over 95. 58 divided by 95, it's going to be 61% chance of pulling a blue and then a yellow. And if you guys are wondering, why is the percentage so high? Remember, our OR percentages are going to be higher. And then also, if you look, most of these are blue and yellow M&Ms. So it's going to be a high percentage. There's only a couple red, a couple blue, a couple brown, some orange, and a green. Okay, we've got one more example. I'd like you to go on and do that one on your own and pause the video, and then I will show you the answer at the end. Okay, last slide. So we're doing without replacement, and we are doing OR probability. So it's the probability of picking an orange M&M and not replacing it, and then picking a green one out of the same pile. Okay, here's my pile. There's 3 orange M&Ms out of 20 total. Okay, so we have now picked our orange M&M. Now we want to pick a green M&M, but we didn't replace the orange. So now our total is 19. So there's only one green M&M, so that's 1 out of 19. So if you notice, the chances are going to be much lower. Our final percentage is going to be much lower because there's not very many orange and green M&Ms, and that's okay. So we want a common denominator. The common denominator for 20 and 19, unfortunately, is just 20 times 19, so 380. so it's kind of ugly. But that's okay. So we've got 20 times 19 is 380. And 3 times 19 is 57. Okay. And then this is just going to be 20 over 380. And we're ready to add now. So 57 plus 20 is 77. And that is our fraction. Okay, and this can't be simplified, so 77 divided by 380 is going to be 20. Oh, I need to get my marker up. So 20.3% chance. Alright, and that is all for the notes today.